Okay, just to review what we have done. Right? We have defined our electric current to start with, and then we have derived this equation. Current is the flow of electron. A is the cross-sectional area, that one. V is the drift velocity. E is the charge on the electron. N is number per unit volume. Now under current density, we define our current density as current divided by cross-sectional area. And from that equation, we derive our NEV. Then we define a new term. Our conductivity is J divided by E. And you can roughly think of it as like resistance is the ratio of V over I. This is why we will introduce this topic, electric conductivity and resistivity. Right. Syllabus-wise, we are going to derive this equation of conductivity. Then we are going to define this formula, resistivity, and then how to use this formula. And we have studied Ohm's law in your STPM. You want to say that this is also a possible relationship for Ohm's law. And then explain the dependence of resistivity on temperature for metals and semiconductor using this equation. Then discuss the effect of temperature change on resistivity of conductors and superconductors and semiconductors and superconductors. Okay, so that's our target for 14.4. Same. There's your wire, cylindrical wire, cross-sectional area. That's the length. That's the potential difference across the wire V. Page 82. Right? Remember our force on electron in electric field is F equals to EE. Right? And then there's our motion, accelerated motion. So we think of the electron from collision to collision, it will collide with the ions, and then it will give all the energy to the ions. So it will stop. It will start from rest, and then end with a drift velocity V. Right? So V now becomes a drift velocity. A is the acceleration. U is the initial speed, is 0. Always start with 0 because it collides, it gives all the energy to the ions. That's our model. Right? That's the best we can estimate. Electron lose all its energy to the metallic ion. So our U equals 0, so it becomes AT. Then we replace our A with F over M. Right? F equals to MA. So A is F over M. Then replace the F with E over E. You see here. Right? EE M over T. T is called the time between collision. Right? It will collide with a positive ion, deflected, accelerated, and then collide with another positive ion, deflected, and then accelerate again. Right? V is the drift velocity. Right? And our current density, J is sigma E, and then we have also called it NE. Right? We have derived already. Current density is NEV. So now we can replace that V inside here. Right? Sigma E, that one, current density, and NE times that is your replacement for drift velocity. So the E and the E can cancel off, capital E and capital E can cancel off. Then we can simplify it, and E squared divided by M T. Remember, M is the mass of electron, E is the charge on electron, N is the number per unit volume, T is the time between collision. Okay, we have derived the formula. Any comments so far? Can we go forward? As long as you understand, you have to go back and review yourself. Then there's your SPM work or O-level work. Resistance is the ratio of potential difference across the conductor that V divided by the current flowing through the conductor. V divided by I ratio. Right? Potential difference is in volt. Current is ampere, so it's volt per ampere. We give you a special name ohm. A property of material that measures the resistance to flow of current. Nothing much, just memory work, that's all. Okay, let's go to the next slide. Okay. Same, we are using the current, potential difference, the length of a conductor. This is your wire. Resistance of wire is R. Depends on material of the wire, directly proportional to length, and inversely proportional to cross-section area. And we can do an experiment to show this relationship. Then we have our R equals to rho L over A. Right? That rho there is proportionality constant. It's called resistivity of the wire. Okay, we can rewrite that. Take our A across, take our L down. That's our resistivity. So we can put our A equals to 1 meter square. L is 1 meter. Then our resistivity is just the resistance. Resistance of material of wire is defined as the resistance of wire of length, unit length, and unit cross-section area. Right? Unit, this is ohm. This ohm, this meter square. Length is meter. Cancel the meter. We still got 1 meter, so it's ohm meter. Okay. Yeah. Or that's a short form to remember it. Resistivity is R, and area equals to 1. L is 1 also. Okay, now page 83 in your note.
Yeah.
Don't need to memorize. Right? That is the value. Slightly different value given in your book is okay. They will give you in the exam is required. The idea is to roughly know what is it. Metal has low resistivity, can very low. You can see that. -8, 10 to the power -8. Non-metal has high resistivity. Non-metal is non-metal.
Manganese.
10 to the power 4 insulator, 10 to the power 13 to 18. Right? That's your insulator. Resistivity of semiconductor. Yeah, there's a semiconductor, germanium and silicon. High compared to metal. High compared, but lower than non-metal, lower than insulator. That's all we need to know roughly. Don't need to know the value. Know the value so that in exam we calculate, we know roughly whether we have made any mistake or not. It's 10 to the power -8 here. Okay, now we want to relate resistivity to conductivity. Right? There's a formula for resistivity. Right? We say the length is L, 1, area is also 1. Conductivity is the reciprocal resistivity. Yep, 1 over rho. So we just take this rho down, take L up, take RA down. That's all. That's how we derive the equation. Plus conductivity is the length. Right? Where we put R equals to 1, A equals to 1. That's all. Of you length of unit resistance and unit cross-section area. Now remember we have got the unit as Siemens meter -1. This one is ohm meter. Okay. So Siemens is basically ohm meter -1. Okay? Siemens is very rarely used. We usually call it ohm minus 1. Okay. Got a lot of homework to do. I think you have to do it by Saturday. I say there's no shortcut. So as I always scold you, don't do it. It's just like a gardener or a farmer. He doesn't plant the field, he will go hungry. He want the fruit of his labor, he have to work hard and plant the field. So same like you.
At least he doesn't have to think much,
He is physical work. Yours, you have to use mental work. Yeah, that's a different. Because you are academic. He is more physical. Unless you want to be a
Physical more
farmer.
easy.
Unless you want to be a farmer. Try this question using the formula we just give you.
Okay.
Remember to change to SI unit. Answer is 0.013. You should be able to get that. And
Teacher, the wait, 1.69 times 10 to the power -8, you put there resistivity, isn't that density?
that one is your resistivity. This one?
I
That's your
thought that
area.
was density.
This is your SPM work. Nothing much. Just to review your SPM work and relate it to A level as well.
Yeah, got it, sir.
Right? Just to show you that the resistance is very low. We don't work with this low resistance usually. So that's the reason why we use it for, we use copper wire for connecting in your circuit. Okay, we are all right. Let's carry on. All right, calculate that. I will send you new notes. Separate the exercise so that you can print out your exercise and then work on it. If not, it's very difficult. Identify where's the area, where's the length. Right? Area is perpendicular to the current. Length is parallel. Right? That's the current. That's your area. That's your length. Into the formula. Can get the answer.
Yeah, can.
Try to B. Identify where your current, where's the area, where's the length.
Wait, direction X, direction Y.
Okay.
Yeah, okay.
Okay, let's carry on. Ohm's law. Right? There's your SPM work. Let's review it. Current flowing through a conductor. There's your conductor. There's your supply. Right? There's a conductor there. There's a current. There's a potential difference across the conductor. Is proportional to potential difference. I proportional to V, provided the physical condition remain constant. Usually physical condition we think of temperature lah. Right? Or in mathematical form, V is proportional to I, or I is proportional to V, right? And R is your constant, right? Or we draw a line, a graph of I against V is a straight line passing through origin. So we can rewrite our equation for resistance, right? That is your V equals to IR. Rewrite that, subject the I take out to the other side. We got that. So we know that the gradient gives your 1 over R. Right? Ohmic conductor, the material, right? Any material that obey Ohm's law is called ohmic conductor. Usually wire lah. So the graph of current and voltage of an ohmic conductor is a straight line passing through the origin. And the gradient is 1 over R. Okay. Can? Okay, SPM work, nothing much. Right? Metal follow or obey Ohm's law. Right? For most material, the resistance is not constant and changes with the applied voltage. That means as the voltage changes, the resistance will change. What do we mean by physical condition? Right? Ohm's law apply only that's the resistance is constant, provided the physical condition remain constant. That means you must make sure that that is constant. Before you can say the resistance is constant. Physical conditions are temperature. Right? Temperature can change the resistance. Strain, right? You're stretching or bending the metal, it changes the resistance. In metal, resistance increases with temperature. In most practical circuit, heating is unavoidable. You cannot avoid it. Wherever you turn on the current, it will start heating up the wire. Consequence of passing current through a conductor. So the resistance of hot component in a circuit will be more than when the circuit is switched off and they are cold. Right? Just like a lamp, when it's cold, resistance is low. When you heat it up by turning the current on, it lights up, the resistance increases. Right? Other thing would be stretching, strain, stretching force. Applying a stretching force to a wire makes it longer and thinner. Right? As this diagram show you, dotted line is the original size of the material. When you stretch it with a force, area becomes cross-sectional area becomes smaller, length becomes longer. Right? Remember, the volume is always constant. Okay, so we can see if the length becomes longer, the area must become smaller. That's why it becomes longer and thinner. Right? So that is what you have learned in the SPM. Right? Ohmic conductor, filament lamp, that's your diode. Okay, the next thing is you want to show that this is another way of writing Ohm's law. Okay, so let's start with Ohm's law and the relationship J equals to sigma E are equal to each other. Right? That means this is another way of writing Ohm's law. Okay, same. We work with a resistance of a wire carry a current I. Potential difference across the conductor is V. So R is V over I. That's our definition. Conductivity of wire of length L and cross-sectional area A is given by that. Right? Conductivity is 1 over resistivity L R over A. Right? That's your Ohm's law, remember? That's what we have derived for you earlier. Conductivity is just that. Take our R across there, take our sigma down. We got that formula. Right? Take our R up, take our sigma down. Get that one there. Then replace this R inside here. Right? Or replace this R with V over I. V over I equals to L sigma A. Okay, remember we want E, we want J. So we can take our I across, take our L down. Right? Take our sigma across. So we got sigma V, take our L down. That's our I up, I over A. So that's what we get. This is our J, this is our E, this is our sigma. Okay, that's how we show the relationship. Basic is to know Ohm's law and know that relationship and then play around, that's all. Okay. Resistivity and temperature of conductors. Resistivity of metal increases if temperature increases. Right? When the temperature rises, the resistance rises, or the resistivity increases, same thing. Right? Whereas conductivity is 1 over resistivity. Conductivity of metal decreases with temperature. Okay, let's try to explain why this happened. Right? There's the formula we derived earlier. That's the mass of electron. There's the charge on electron. There's number per unit volume. There's the time between collision. Explanation. Right? Why as our temperature increases, our conductivity decreases. Right? N is the number of charge carrier per unit volume. This one is constant, cannot change for metal, for conductors. As temperature increases, the metal ions vibrate with greater amplitude. So probability of collision increases. Right? Previously, between one atom and another atom, there may be a gap. It can avoid the collision. Now it's vibrating larger amplitude. So there is more likelihood of collision and then being dispersed or deflected. Right? Electrons will be deflected or dispersed. Right? So we are going to look at this use this formula T, time between collision of electron and positive ions. So our T decreases, right? T decreases, so our conductivity decreases, or resistivity increases. Can?
Sir, I have a question.
Yep.
Is this chapter connected to the previous two chapters? Or is it on its own?
We are just developing. It's actually a new topic which we'll be
So
using.
it's not related to the previous two topics, right?
A little bit only lah. Only electric field strength related to the first topic.
Oh no, I thought can do revision this, then the other two lah. Sure.
Only the first topic we are using part of it, electric field strength. That's all. Definition of electric field strength.
Okay.
Paraconducting plate. Other than that, very little related. 14 and 15 are related. And you have done a bit of it in your SPM. So I expect you to do your checkpoint 14.4 and 14.3. Okay, go back and review. Okay, resistivity and temperature. Right? There's a straight line. Right? There's your R naught. There's your reference temperature, T naught. You can use theta if you want to. Theta is in degrees Celsius. T is in Kelvin. So graph of R against temperature for metal is shown. It's linear, it's a straight line. Yeah, it doesn't pass through origin. So we can rewrite the equation R naught 1 plus alpha T minus T naught. Okay, memorize it. Where R is the resistance at a reference temperature. Usually we take it at 0 degrees Celsius. Our reference temperature, but it's up to the person who measure it. Right? R naught and T naught is the same thing. Reference temperature, reference resistance. Alpha is called the temperature coefficient of resistance. Right? Can rewrite the equation. Take our R across, R naught across there. Right? Open up, expand it. Take R naught, becomes minus R naught. Then alpha. Right? There's your R naught and T naught there. Take it, cross multiply there. We got that one there. This is a better equation to memorize, easier. Right? A change resistance, a change in temperature divided by R naught. And then this is a change of resistance. That's a change in temperature. So R minus R naught, T minus T naught is the gradient. M over R naught. Right? Unit per Kelvin is quite small for copper. No need to memorize. Know that it's small, that's all. Know how big it is so that in the exam you are asked to calculate, you can know whether your calculation is right or wrong. Okay, so I just try to help you summarize it. Increase the resistance is increase the resistance per unit per degree rise in temperature divided by reference resistance. Okay, try that. Basically using this formula, that's all. This formula. Can? Yeah, use this formula. Calculate your alpha first. Right, you are given that one. R. And then this is at 0 degrees. There's a reference resistance 100. Right, that one is 100 minus 0. Yeah. R naught is 100. Calculate that. And play with the formula again. Okay. R naught is 100. 1 alpha, we'll calculate it up. And this is 50. Okay. Can?
So that's for A.
That's for A.
Okay.
I think B nothing much. B is given you already. Only C only. Calculate the temperature when the resistance is 110. Okay, so I've done something wrong.
Teacher, how long more left, sir?
We have finished our time already. We are exit already. So we do this last question, then we'll stop.
Okay.
That's all. Put in the formula. So you should be able to do your homework already. You'll finish on Saturday. So Saturday 9 to 11. Unless you want to have 1 hour earlier. Can? That's all.
Can?
Just use this formula. Cross multiply. It is not across, take the alpha down. That's a new value. R. That's your 100. The reference temperature is 0. Temperature is 0. And R naught is 100. And this one we already calculated there. Okay. We will stop here.
Wait, teacher. The alpha where you got 0.0391, sir.
Yeah. Yep.
Where? No.
Okay or not?
Teacher, you never show the final answer for A.
Yes, answer. Yeah. 119.5, 119.6.
Yes, okay. Then the boy wants the alpha.
One alpha, the same thing, you calculate already. Right? T naught is 0. Right? From here. Put in our value, that's all. Yeah, using R naught as 0.
No. My question is here, where you got the 0.00391?
Yes, here we calculate the first one.
Huh?
There.
Where?
The previous one, this one. You can put a 1 here if you want to.
Oh, okay. Got it.
Yeah.
Yeah, okay.
Okay. You completed anything else you want to clarify?
No, let me study first, just.
Make sure you do your homework. As I say, you don't do your homework, there's no progress. I will make you do in class. Right? We have exceeded already. That's your time. You want to know. Exceeded by 20 minutes. Okay, we'll stop here.
Okay. Okay, thank you, sir. Bye.
Bye.